Okay, I just pasted into the Zoom chat what I called an agenda with approximate timings, but it might more correctly be called an approximate agenda, because the purpose of this is informational, and we'd like to respond obviously to questions and comments from attendees. So you'll hear from a few of us talking about different elements of SciMMA, and we'll introduce ourselves as we go. My name is Adam Brazier. I'm the Chief Architect for SciMMA. I work at the Cornell Center for Advanced Computing. One important logistical note, some people were unable to attend at this time, and so we are recording this session so that we can then distribute to them the recording, because they're interested to find out what we're talking about. So do be aware that you are being recorded, and that some number of people will receive that recording. So I will be, please do feel free to ask questions. I will be looking for raised hands in the participants window. So if you use the, actually, I can't even see what happened to the raise hand facility. Oh yes, it is there. So if you do raise your hand, I will try and direct whoever is speaking towards your question. So first of all, I'd like to introduce Patrick Brady, who's the SciMMA PI, and many of you will be familiar with him from his LIGO work, and he will give you an overview and introduction to SciMMA.
Thanks, Adam. Sorry, I've lost track of where I am in this mix of things. All right. So yeah, as Adam said, I'm just going to give you a brief update on what we're up to and the type of thing that we're trying to actually do at the next step. Hopefully we'll have a little bit of time for questions and discussion. I'm just going to share my screen if I can get back to it. Apologies about that. Okay, can you see that okay?
Okay. Yeah, looks good to me.
Okay, great. In fact, let me just go back here one. So just to let people know a little bit about the background, this project started as a result of a workshop that was pulled together by the National Science Foundation back in May of 2018. A group of us came together, chatted for a while, wrote a white paper. Subsequently, we decided to propose for a community planning grant, which is the first of the two grants referenced on the front page here, which we were ramping up when we were made aware that there was a second opportunity to actually seek funding under the Harnessing the Data Revolution frameworks proposals. And we got an award to continue the community planning, but build into some prototyping infrastructure, and also then try to actually develop a strategic plan for an institute that would be really serving the community. So it's meant to be a hub. It's not meant to be just a single set of PIs or things that work under the funding, but to be broader than that. We're still trying to find our feet and find our way through this. It's a large distributed effort, and it's also, of course, needs incredibly broad and great engagement to cover into multi-messenger astrophysics. So moving on to slide 2, the activities that we undertook in 2018-19 included a few workshops. So we had a deep learning workshop at NCSA that was co-organized by the team there and by the SciMMA group. We had a workshop in New York City in January of 2019, and we had a SciMMA inferencing and machine learning workshop down in Berkeley in May of 2019. We also kicked off a number of white papers that one or two of which have been completed, but many are still actually sort of on hold, I would say, and we want to come back to them this year and get some broader engagement on writing them, finishing them out, and moving forward. The vision that we've been trying to do for the Institute is not one that takes over any of the projects, but it's a place that would actually be an institute without walls, if you like. It would pull together on the very distributed nature of telescope networks, various different large-scale infrastructure and large facilities of the National Science Foundation, and really try to find a way to help to build out the cyber infrastructure, the data science tools, software development and maintenance programs, and also then to build an education and training system for graduate students, postdocs, and others that might be coming into the field. Moving on to the next slide. This is a brief overview. I'm not going to read through it. Oops, sorry. I'm not going to read through it in detail. You can take a look at the various boxes and how we're hanging things together. But I think the main point is in the goals, the 2 bullet points that are in the second subheading. We had 2 goals for this Harnessing the Data Revolution grant. The first was to prototype a couple of solutions that we think address immediate needs for multi-messenger astrophysics. It's sort of based on our perception of a gap, or in some ways, really, in some cases, identification of a way in which we could actually reduce the total cost and enable more efficient sharing in science. That's the first one, and that is what's bold on this slide number 3. The second part of the goals was to do a baseline design for an institute to support multi-messenger astrophysics, with a long-term goal of that being supported through the end of this decade and into the 2030s. So it's a somewhat ambitious goal, and we're still trying to pull together the details. Now, for people on this call, and I've lost track of exactly how many we have, well, we've 37 people. I know there's a broad set of people that are sort of participating more directly in the project at the moment, but there's also a set that are just joining to hear what we're up to. All of you are pretty familiar with the multi-messenger astrophysics science drivers. When we've been talking about this, have sketched out kind of 3 different pieces, one based on high energy neutrinos, one based on gravitational waves, and one based on other objects, for example, a supernova in the galaxy or in the local group. Now, with that in mind, the thing that we're focusing on right now is getting ready for the first part of this, which we figured is something that we really want to be able to do. And in conversations with LIGO, represented in some part by me, by IceCube, by people involved with Vera Rubin Observatory, and also then with the broad set of people engaged in follow-up of gravitational waves, we've been emphasizing the ability to do what we call early warning alerts for binary mergers using gravitational waves from the LIGO Virgo CAGRA worldwide network. So our first step into prototyping is addressing 2 different areas. The first one is identity and access management. One of the things we find happens fairly regularly is that when you're trying to actually build up and share information that might have different levels of security and access control, it becomes quite a pain in the neck that you have people who use all kinds of systems. Doesn't matter, there are many that you can use, but the trouble is that trying to get them to interoperate can be a bit of a pain, and often leads to quite a lot of confusion. So one of the things we're trying to do is to build out a modern identity and access management system that would show how federated identities can be used to facilitate efficient development and sustainability of long and short-term collaborations, in fact. The second thing that we focused on is a publish-subscribe message passing system. The idea is that we know that alerts have been a key piece of the infrastructure for multi-messenger astrophysics. GCN has served us very well as a community to be able to share information based on many people having access and knowing what was there. But as we try to scale out the types of messages that are passed, the speed at which we want them to be passed, the reliability, and other things, there really is a need for a better publish-subscribe system. And so we've got a prototype of that we'll say a little bit about today, but later on we'll tell you more. So the pub sub system, we're calling it Hopskotch. As of right now, this is the type of situation that we envision. There's the pub sub system in the middle, and you can see the various different systems that could interact through it. Within this context, the idea is that if, for an example, an observatory is a producer at one time, they would publish messages into Hopskotch, while a user might subscribe and listen for messages from that producer or any list of producers. You can then see that this then allows you to build a set of services whereby this messaging system underlies it as a fabric. And our goal is to put out this system with a very thin client with a fixed API in it, and to sort of hide some of the pub sub architecture under the hood so that it's not needed by the publishers and subscribers, at least to get involved. People who want to use more sophisticated tools would, of course, dig deeper. There's going to be a little bit of an update later, so I don't want to just read through all of this. If you read through the plan functionality on page 7, you'll get a sense of various things that we imagine happening with the system. It's worth mentioning that we're building on experience from ZTF and paralleling somewhat what's being planned for the Rubin Observatory by using Kafka as the underlying technology, even though, as I say, we're building a thin client over the top that actually makes it easier to access with. So that's the first thing. Whoops, sorry. I thought I had one more slide. I guess I've forgotten it. So in addition, the other thing that you'll hear a little bit about today is the identity management system and sort of where that is. Now, I want to finish this slide, and then we can have a few minutes for questions, perhaps, to just sort of say where we're going in the next, over the summer, and then heading into the fall and next year. At this stage, we do want to reinvigorate the baseline design of the Institute. To do that, we have this vision for an institute that serves the MMA community. It isn't meant to supplant it. It isn't meant to overtake it or take ownership of anything. The idea is to provide some substantial, hopefully, resources that can assist in best practices for development of algorithms, cyber infrastructure, systems for data-intensive multi-messenger science, and also education and workforce. Now, the approach we're going to take over the coming months is we're going to start. We've been having weekly telecons, and we're going to start having a monthly telecon on Tuesdays, the first Tuesday of each month, that we're going to devote to broader-based things to try and reach out into the community. We'll pay some attention during those telecons to where we need to go next with the white papers, and then try and work through over Git, mailing lists, Slack, etc., to get to finished products on those towards the end of the summer. We're also heading into opening up the development of the few prototype tools that we're working on, and so we'll start with Hopskotch. One of the things that we're hoping to do with this is to promote some development and engineering practices that we've found to be useful, and we sort of have deliberately designed around agile development and within the context of the software development that we're doing. The goal being that that's somewhat well aligned with how a research community operates, and so we want to try and not fit a square peg into a round hole. The other thing that we want to do is we're going to host a workshop, which we'll tell you more about later in the agenda. And also want to start thinking about how to benefit from collaborative training exercises where we can actually train up some students and postdocs on best practices related to data science and also to software development and engineering within the research community. So that's what I have for today. Happy enough to take some questions, and also I should actually throw out for others on the call, if anyone wants to add comments about things that we've been doing, you should feel free to do so. Adam, I'll hand it back to you to watch the hands up and to facilitate any discussion.
Yeah, does anybody have any questions they'd like to ask at this stage? There'll be a wide variety of familiarity with our organisation and what we've done so far. So if you do have anything, just raise your hand. Okay, well clearly you answered all potential questions. So the two technical products we're going to talk about today are the Identity and Access Management System and Hopskotch, the pub sub system. And first of all, we'll talk about Identity and Access Management, and Warren Anderson, who's been leading this effort, will give a presentation on it and where it's going. And this will also be one of the things that we cover in the workshop, about which we'll talk a little later.
Thanks, Adam. So I'm just going to see if I can share my screen here. Is that coming through?
Yep, looks good.
Okay, thanks. I'll just go to presentation mode. So as Adam mentioned, my name is Warren Anderson. My background is that I lead the Identity and Access Management group for LIGO. And I am leading the Identity and Access Management effort for SciMMA as well. So let's see. Oops. Okay. I thought I'd just start by introducing the concepts of identity and access management briefly, because I'm not sure how widely scientists who are not involved with this kind of effort are familiar with the concepts. So by identity management, we're trying to answer the question of who is a collaborator and how are they associated with the collaboration. Very importantly, what are their roles and responsibilities within the collaboration? And in the enterprise and higher ed world, where these things are thought about quite a bit, this is often closely tied with access management. So what systems can a collaborator log into? What data can they read or edit or create? Who's allowed to invite a new collaborator, or who's allowed to approve the addition of new collaborators? As Patrick mentioned, our approach is going to leverage federated identity. And what this means is that we are not going to have a system where you log in with a SciMMA password and user ID. We're going to be able to use the user ID and password that you have from your university, from your lab. If you don't have another suitable one, ORCID, the research IDs do work with our system as well. So no new identity or password needed. This is a benefit for people who want to collaborate, obviously, not having to get registered with a new password in a system. It's also a benefit for the people who are managing things, not to have to have and secure a new way of authenticating people, a new Kerberos KDC or something like that. Once one of the nice things about federated identity then is you log in with your university or research lab credentials. But that allows you to access resources at any participating institution. So it's no longer the case that in order to, for instance, access a piece of infrastructure at Cornell securely with a login, that you have to have a Cornell username and password, and Adam has to find some way to get you one of those. So services can be hosted anywhere and still leverage our system to be able to use your federated identity to get in. The other nice thing is that many commercial services, AWS, GitHub, G Suite, they assume that they're dealing with enterprise consumers who have a single source of identity. And so by having our federated identity system, we basically are translating your identity into a SciMMA identity or into a collaboration identity. And so for the purposes of these commercial services, everybody who's in the collaboration looks like they belong to a single organization, which is what those services expect. So to summarize then, we're using tools that collect your identity information from your university or research institute and add to that extra identity information that's related to who you are within our collaboration or your collaboration, who you are within a collaboration that we're hosting, and how you fit into that collaboration, what roles and responsibilities you have. And then it can send all of that information on to services downstream to consume so that you have the correct accesses, the correct privileges that somebody with your roles and responsibilities within the collaboration should have. So to go on to the specific tools we're using, the first one is COmanage. It's a tool that originated in Internet 2, but has since gone on to have a more independent life. The way that this would work for setting up a collaboration is that a COmanage administrator, currently that would be me, would receive a request to create a new collaboration and would set some configurations to create that new collaboration within the platform, and then send out invitations for people who would manage that collaboration to enroll. Once we get the managers in, we can give them access to define various things, how they want to enroll the rest of the people who are going to collaborate, whether they want to invite them, or whether if there's very, very many of them, so many that inviting each individual would be difficult, we can create a link that they can just log into and request, either with or without approval from somebody to be added to the collaboration. And you can have multiple enrollment processes per collaboration. We can set up working groups, access groups, give managers to each of those groups so that when somebody wants to join, we have a responsible person who can make the decision to add them to those groups or not. And then once we get everybody that we want into the organization, well, as we're getting people in, all of that information is exported into LDAP. So LDAP is a directory service that's widely used by many products, and the LDAP that we have will be available to look at by any service that's involved in the multi-messenger astronomy community. And people will be able to pull down the information about what collaboration you're part of, what your roles and responsibilities are, what your rights and access rules should be, and then can use those to make decisions about how you use the service that they run. The second piece of infrastructure that we're using is called SATOSA, which is short for a SAML to SAML proxy. SAML is the security assertion markup language, and it's basically a a way to send secure authentication information around that's particularly well suited for federated identities. The nice thing about Setosa is that when you log into Setosa with your institutional identity, your Cornell or UWM identity, it translates it into a collaboration identity so that services down the road that contact it see who you are to the collaboration. So this is how that translation between institutional identity and collaboration identity happens. So again, we're set up to accept logins from very many different universities, labs, observatories, etc. There are still some institutions that don't play nicely with federated identity. And as I said, we have things like ORCID or Google as workarounds for them. So we can leverage non-research and education identities, but we prefer, we prefer the research and education identities. Once you're logged in, we decorate your identity with all the things we know about the collaborations you're in and how you fit into them. And then services downstream from us who want to use our identities to govern access to their services get all of that information. And again, this includes commercial services. A lot of commercial services such as Amazon Web Services or GitHub can easily be configured to use these as a login server. And in fact, the instance that we have right now is already doing this for the AW instance that we'll see in the next section of the presentation, I believe. The actual infrastructure that we use, we are not running ourselves. We have a contract with CILogon2, who is basically a for contract service hosted at NCSA at UIUC. And this allows us not only to get away from the workload of keeping our systems, our platforms up to date, but also gives us access to domain experts, and in particular, Jim Basney and Scott Caranda are closely working with us on this project. So just to conclude, one of the things that we said that we would do for SciMMA is produce an identity and access management platform for the multi-messenger astronomy community. We have a prototype of that available. It uses federated identity, so you already have the login credentials you need. It allows for a way to quickly and efficiently create collaborations and define how they are organized. It gives you, the people in the collaborations, forming the collaborations, control of how to assign the roles and responsibilities within it. And then it is able to communicate all that downstream to services that, again, the community might be providing, so that we can say, this person is from LSST and they should be able to do the following on this service. So all that information is available to the services that are set up within the multi-messenger astronomy community to be able to provide that access. And that's all that I wanted to say for right now.
Thanks very much, Warren. This to me is actually, although it's technical and not directly science, this is actually very exciting to me as a sort of enabling technology, because if you've got a bunch of data and you would like to get a data scientist to look at it, or you've got a new grad student, or you've got a software engineer and you want to onboard them quickly, this will make it much easier to spin up and manage collaborations than would have been the case. And in fact, during the workshop, we're going to have one of the technical sessions will be showing how you can integrate applications with our identity and access management system. Does anyone have any questions directly about this? I mean, technical questions or functionalities?
for general questions.
Okay, Curtis McCulley.
Yeah, this sounds great. Sounds a lot like the Google single sign-on kind of buttons. Are you going to integrate that with that as well?
Google single sign-on is a similar technology. What it does not quite as easily allow is for the organizational part of the infrastructure. So defining the collaboration, defining who has what roles, putting them into access groups, all of that is not as easy with the Google solution. However, as I said, G Suite, for instance, is a Google product that this allows you, that will accept this as an identity source and allow you to set up a G Suite instance where it knows that who's in the Hopskotch devs group and can see all of the security secrets. I don't suggest we keep those in G Suite actually, but whatever the access management that you need to have is. And also Google is one of the things that we will accept as an identity provider. So if Google is your preferred username password that you want to use for everything, you can use it for this as well.
Well, thanks, Warren. So this has been one of the two initial technical projects we identified, and obviously, as you see when we talk a bit more, if we have time, about the roadmap going forward, and Mario will also touch on some of the future things, there's going to be more applications to come, but to begin with, we're building the enabling cyber infrastructure and making it robust and scalable, so that we can take it out to production without having to go back and fix everything and sort of glue it together with prayer and baling wire in the way our forefathers did. So the next thing we'll talk about is Mario's going to talk about Hopskotch.
All right, just let me verify that you all can hear me.
I can hear you and I can see your presentation.
The slides, excellent. All right, thank you, Adam. Thanks everyone for coming. Just to introduce myself, I'm Mario Juric. I'm at the University of Washington at Dirac Institute, and our background is that we've been heavily involved in Rubin Observatory alert system and the ZTF development, and we're transferring some of that know-how and experiences to SciMMA. What I'm going to be talking about is Hopskotch, and this is what Patrick introduced as our PubSub system. So it's a messaging system. It's a system that allows you to send a message potentially to either one particular group of collaborators or to the broadcaster, to the broad community, in such a way that ensures that that message will be sent, will be received, will not be dropped, and all of that will be done with minimum latency possible. To give you an overview of Hopskotch and the team, we are currently focusing on standing up a simple PubSub system. So basically make sure that you're able to send a message and that the message is received. We're using, as the underlying technology, we use something called Kafka, but from the point of view of the user, all the communication, it's virtually all communication is done through Python clients where applicable. It is all currently in the prototype phase, and you'll see a few very short demos at the very end of this talk by our team members. One of the experiments here for a potential future virtual institute is that we're using a distributed Scrum process to develop this product. You'll see this list of developers that are across at least 3 time zones, yet who work together to deliver a constant stream of increments on a 2-week schedule. And we also already, although in prototype phase, we have the ability to install the necessary packages from both PyPy and CondaForge. And there's rudimentary documentation. So our goal is to make this very easy to use for the user in the end. To motivate this a little bit, this is a slide that I lifted from an older ZTF presentation on why is this hard? Why is message passing hard? Because there are a couple of things that all have to happen or all have to be true of the system at the same time. When dealing with MMA events, you really want to have strong delivery guarantees. You do not want to miss a potentially critical message from LIGO, or you do not want to miss a potentially critical message with a piece of follow-up from a telescope. At the same time, we're now seeing telescopes that are coming online with large throughputs. Rubin Observatory is one example of such a machine that can send up to 10 million messages per night. So you want strong delivery guarantees, and you want high throughput at the same time. We are likely to have many clients. The clients here for MMA alerts are all the potential observatories that are going to be trying to do follow-up. These observatories are going to be all over the world. So we're talking about operations over a wide area networks. You want also to be resilient. You want to be able to, for the system, if it goes down, or if it goes down in some, if it gets degraded in some way, to recover in such a way that nothing is lost other than time, other than potentially an impact on latency. And you want reliability, so you'd like the system not to go down if you can avoid it. So if you combine all these requirements together, you end up with something that's actually quite technologically complicated to deliver, deploy, and operate. So we were facing these challenges early on when thinking about Rubin Observatory and then ZTF, and the MMA problem is quite similar to all of that. So we're all in this type of situation, have this kind of problem. This is not new. There's a rich history and there's a much useful prior experience with alerts from distributing alerts from both the VO, GCN, from PTF days and IPTF days. And I think the main new challenges here are the needs for scalability and the increased needs for robustness, especially in the MMA era. So to make sure that an errant router will not cause a message to be completely lost. And this is something that we're not the only ones who are facing. The industry has the same problems. So there are billions of events flowing through compute systems of largest companies out there. There's Google, there's Amazon, and Microsoft, that also need to be serialized, transmitted, streams fused, results classified, active deployment, et cetera. There's actually a very interesting mapping between our problems and what's already happening in the industry. And as you might imagine, the industry has worked to solve some of these problems and develop solutions. And I jokingly show this slide here, and I'm describing the situation about 5 or 6 years ago. We were thinking about this for the first time, and one of our really good researchers, Maria Patterson, has come to us and said, look, here are these systems that originally developed LinkedIn, maybe we should use that. And our initial response was, we're too busy developing our astronomical solution. And unfortunately, she was persistent and pointed us towards what we use now, which is Kafka. So Kafka is the system that currently underpins Hopskotch. As Patrick and Adam said, we're designing Hopskotch to be relatively agnostic to the actual transport substrate that Kafka is. But still, Kafka is what allows us to have a lot of what allows us to tick off many of the requirements on that initial slide that I showed you. It's a fault-tolerant, scalable, high-throughput, low-latency platform for handling real-time data feeds. It implements a publish-subscribe paradigm, so it's a pub-sub system. Producers publish messages into a topic, consumers read messages from a topic. What those messages are does not depend on the system. It depends on the rules deployed over it. So messages could be alerts to MMA events. They could also be notices about where a certain telescope is pointing or where it plans to point. The important thing for us is that Kafka allows both at least once and exactly once delivery semantics. So it will guarantee that you will receive a message at least once, and depending on how you deploy it, it can also guarantee exactly once semantics. And it has good Python and C++ client support, and we mainly rely on the Python support for SciMMA. Now, in principle, if one sets up a Kafka server, then any number of out-of-the-box Kafka clients will already work. The classic one is called Kafka Cat that you can install from Conda, from Conda Forge, but those are quite rudimentary. For actual end-user science use, for astronomy use, we have developed a fairly thin wrapper around those existing Kafka clients and libraries called Hop. There are two reasons why to use Hop. One, it provides a very Pythonic interface to Hopskotch. Underneath, currently, there's Kafka, but the way we've written Hop, even if we change out Kafka with something new, perhaps 5 years ago, a different technology may arrive. The way Hop is written is that those changes, potential radical changes in inherently transport technology, should be fairly simple to absorb on the client side. Ideally, you would not see that at all. Hop also understands various message formats. It knows how to parse GCNs. It'll know how to parse via events. It'll know how to transform them from one format to another, and in our preferred JSON serialization. And it's useful as a basis for custom client development. That is, if you're building a client that will, for example, interface your telescope to Hopskotch, then Hop is a nice library to start with. And in just a minute, I'll ask Bryce Cousins from Penn State to demonstrate how Hop works. But before that, let me, just to minimize switching of screen sharing, let me also talk about the server side. Our server implementation currently runs on Kafka 2.4. We've deployed it on AWS. It's presently, it's prototype. It's configured to keep at least 28 days of alerts. What that means is, right now we are sourcing alerts from GCN in this prototype phase. And what this means is that if your client gets disconnected for up to 28 days, which is quite a high number, typical disconnects due to, say, network issues will be an order of minutes, we presume, then no alerts are going to be lost. You'll be able to catch up with everything. I mentioned it's deployed in AWS, but the way we do the deployment, it should be transferable to other systems as well. We are trying to do as much development on public cloud as possible, just because that opens up some interesting possibilities later on, where you might be able to virtually co-locate your servers with our servers if you're in the same availability zone, thus obtaining significantly higher performance. All right, and Ron is going to demo interfacing to that server. So what I would like to do now would be to hand it over to Bryce to just show you a simple use application of the Hop client, just simply to read a message. So don't expect something big here. We unfortunately don't have time to do something more complicated, but just to demonstrate that there's code behind this.
Yeah, because if nothing else, we need 5 minutes at the end to talk about the workshop. So some 10 minutes more maximum.
Yeah. And I think with these two, after these two demos, we're practically done with this presentation. So Bryce, do you want to screen share and show us what you got?
Yeah. Can everyone hear me?
Yeah, we can hear you.
Okay. Screen sharing. Okay. So as Mario mentioned, Hop is the Python package that we've been developing. Right now, it exists on both the Anaconda package repository as well as the Python package repository. So here we can install the Hop client from the SciMMA Anaconda channel. And it'll just run through the build environment and install as a full package. And we can do the same thing with the package, Python package index with pip. And that'll give us the Hop client installed. And so at the core of Hop right now, we have the publish and subscribe features, which are essentially what allow us to send and receive messages right now relying on the Kafka broker instance. And so if we have a sample message that we want to send, in this case, a GCN circular with this text here. If we want to send this, we can use Hop's publish function, which allows us to talk to the Kafka broker pointing to what's the SciMMA server, which is a local Kafka broker on its port. And for this, we're going to create a topic, which is what organizes the passing of messages in Kafka. Well, we're calling that GCN test. We can connect to that topic securely using an SSL configuration. And now finally, we just want to pass the message here. And so what this does, it will pass it. And then what we want to do is read that. And we do that with Hop's subscribe function. And similarly, we point Hop to a Kafka broker URL, the same one that we used for publishing. And again, connecting securely with SSL. And what we do here is read from the earliest possible message. Since we published that message in the past, we want to read off an older message rather than waiting for a new one. So we will specify earliest to read that and have that flow through. And the client will wait until its own timeout for new messages to come in. So if we want to, say, wait for a new message to come in, we can specify that timeout to be a longer period of time and then let the client wait. And in the meantime, we can publish a message that will then get read in real time. So the use case here being another user also using Hop client wants to publish a discovery that they have and over here. And then a subscriber is waiting for that message so that they can act on that discovery. So again, we'll post that same message and it will be read in real time here on the subscriber side. And this has all been done with a local Kafka instance, but in order to coordinate things on a larger scale, we can use another instance, in this case, a Kafka broker hosted on SciMMA's AWS account, which we're on and we'll get into more. But same functionality here, we're just pointing to the Kafka broker, this time being hosted on AWS, and again, publishing to the new broker. But this will fail because we aren't talking to it in SSL. So to quickly change that, we get the more secure configuration for the development. which is one part of the important access management. And now, once we have authenticated properly, we publish and receive. And so that is the core of what we have for pub/sub management of messages being sent and received. Right now, we're supporting GCN and expanding to VO events and other formats, as Mario mentioned. And we can take questions now or pass it off to Ron to go over the AWS with a bit more detail.
Thanks, Bryce. And this is a deceptively simple example, but what you've shown us. The important thing about this is that it's robust, it's resilient, it can work at tens of thousands of alerts per minute, and it can scale to any number that will be necessary over the next decade or so. I'm just looking at the time, and I know that Ron has a demo, but he also has a movie of the demo, and I wonder, Adam, if we should just distribute that movie to this group later on to save a couple of minutes rather than do it live.
Yeah, I think that might be easier. Would it be easy just to host it somewhere, Ron, and then we can email everyone and tell them where it is?
Sure.
Yeah, I'm sorry about this. Everything takes longer than we think it will.
Yeah. I just want to finish up with this last slide that shows the roadmap, our roadmap for the next 6 to 12 months. So what we want to do is we want to deliver a stable and reliable, still prototype, but a stable and reliable Hopskotch service that will run, that you will be able to connect, not just us when we're developing. It's capable of delivering GCNs, ATELs, and TNSs alerts over Kafka. We want to start experimenting with exchanging things like telescope pointing and scheduling information, and then start developing applications on top of this substrate. So think of them as processors on top of its Hopskotch system. For example, something that will take various formats of messages that we have right now in the community and reformat them in a perhaps a more universal format that can then be adjusted. Translation from unstructured to structured formats, etc. That really will depend on where the community goes with this. We definitely need to add IAM integration that Warren talked about, so that the system knows who is who and can record that. We're putting together a database of received messages so that research can be done on everything that has gone through the system. And the challenge here, particular challenge, are access rights. So how do we ensure that you are the ones who are in control of who's going to see the message that you send? If you're, for example, sending your telescope pointing information and you want only your collaboration to have access to it, we'll put together some kind of a basic web interface, and then integration with TOMS and Treasure Map in particular is something that's quite high on the list to make sure that the broader community gets access and starts leveraging these technologies as soon as possible. So in the interest of time, I'll stop here and hand it back to Adam.
Okay, thanks very much, Warren. Not Warren, Mario. Yeah, so we're going to talk more about this, and actually maybe I can, if I share my screen, I can't, can you stop sharing your screens? Okay, let's see if I can share the right part of my screen. Just wanted to talk very quickly about the workshop where we will cover this, some aspects of this in more detail. And I guess I'm not sharing my screen, am I?
Not yet, not that I can see.
Yeah, let me, okay. So this is going a bit slow. Okay, there we go. So let me try now. Okay, my computer is struggling with the day of Zoom meetings. Can you see my screen now?
Yes.
Okay, cool. So in essence, we'll send out details about this, but this is our plan for a workshop on the 19th of May. This will be all afternoon. These are central times, so we'll probably convert them to Eastern or Pacific. But essentially it'll be afternoon on 19th, 20th and 21st of May. Never too long that it becomes exhausting, and those who attended the HDR 3-day Zoom Telecon will be aware how tiring that can be. So we'll have talk on ongoing activities, and then we'll talk some about the machine learning applications that we're hoping to implement as well, and the platform we aim to build for it. And then there'll be 2 technical sessions. On the 20th of May, there'll be one on actually integrating your applications and your workflows and your spinning up collaborations, whatever, with the identity management system. And that'll be led by Warren, but also people from the COlogin team. And then on the 21st of May, there'll be a technical session about Hopskotch and how you can use it, and potentially not just in multi-messenger astronomy. We already have one client who's interested in moving beyond the field of multi-messenger astronomy. So this is just a draft agenda at present, but we will be sending this out so that you can you can get the details and ask questions and so on about that. So that's all from me. Patrick, did you have anything you wanted to say to wrap up just before we end exactly on time?
No, I think actually, Adam, I think this is the best thing to do is end on time and hope that anyone who has not been involved in the project already will take a look at the workshop and perhaps join us for parts of it that make sense, or for all of it, preferably. We really are looking forward to having a sort of broader engagement and beginning to now get stuck in a bit more detail with some concrete stuff. So, over.
Okay, great. Temporarily, I can't see hands. So if anyone does have a very brief question, please ask it now. Feel free to email me or Patrick or Mario or Warren or anyone else. But I can't see hands, so just speak if you have a question.
This is Zsuzsa. I just added the workshop website to the chat window for everybody to see.
Oh, great. Yes, thanks very much for that. Yes.
With the sign-up sheet as well, there's a link to that. Thank you.
Oh, yeah, thanks, Zsuzsa. And I think 13th of May was when we had for the sign-up for the workshop.
I don't remember actually, but
Okay.
probably yes.
I can check. I can check quickly. Just give me 1 second. I'll just get it.
It's not listed on the website.
Okay, it will be.
11th of May was the target date. I mean, it's not a fixed deadline given that we're doing it virtually, but we were sort of encouraging people to sign up by the 11th of May.
Great, and the SciMMA.org website will also have more activity going forward. There'll be project pages for the identity and access management system for Hopskotch, also for things like the workshops and other activities. So if that is all, I will thank everyone for attending, and we will be in touch with a more detailed workshop agenda, and the next of these general public telecons will be on the first Tuesday of next month, and we'll send out a reminder before then. Thanks everyone.